Welcome to Maths CET JEE Studio. Today I am here with 5 CET questions on integrals. Let us solve all those 5 questions. Here is a first question, that is integration of 1 upon square root of 1 plus x minus root x with respect to x from 0 to 1. It is a definite integral. Now to integrate this, let us rationalize the denominator. Rationalizing factor is root of 1 plus x plus root x. Multiplying and dividing with the same, we have this. Okay. Now integrating from 0 to 1, numerator 1 into, so that can be written as 1 plus x raised to 1 by 2 plus root x, so that is x raised to 1 by 2. What about the denominator? Denominator is in the form of a minus b into a plus b. We can write it as a square minus b square. Square root get cancels out, so that is 1 plus x minus x. Minus x plus x get cancels out and dx here. Okay. Denominator is what now? Denominator is 1. Integrating from 0 to 1, 1 plus x raised to 1 by 2 and plus x raised to 1 by 2 into dx is the term now. This is the given term. Okay. Now let us integrate this. We know that integration of x raised to n is x raised to n plus 1 upon n plus 1. In the same manner, if we integrate this, this is 1 plus x raised to 1 by 2 plus 1. 1 by 2 plus 1 is 3 by 2. Power 3 by 2 by 3 by 2. Similarly, x raised to 3 by 2 x raised to 1 by 2 integration is x raised to 3 by 2 by 3 by 2. As it is a definite integral, let us take the upper limit and lower limit. It is 0 to 1. Now substituting upper limit 1, 1 plus 1 2, 2 to the power of 3 by 2 upon 3 by 2 can be written as into 2 by 3, plus substituting 1 upon 1 to the power of anything is 1 upon 3 by 2 is there. It is like into 2 by 3. This is upper limit substitution. Minus of substituting the lower limit, 1 plus 0, that is 1. 1 to the power of anything is 1 upon 3 by 2 is there. It will be into 2 by 3. So now let us write this as 2 by 3 plus 0 to the power of anything is 0. Okay, here you see this minus 2 by 3 and plus 2 by 3 get cancels out. 2 into 2 raised to 3 by 2 by 3 is left. 2 raised to 3 by 2 can be written as 2 into 2 raised to 1 by 2 upon 3. This is what? This is 4 into 2 to the power of 1 by 2 is root 2. So answer is 4 into root 2 by 3. That is option B. Now let us move on to second question. Second question is integrating from 0 to 1 e raised to x into x minus 1 upon x plus 1 raised to cube. I think it is in the form integration of e raised to x into f of x plus f dash of x. So let us try to take it in this form. What is integration of e raised to x into f of x plus f dash of x? It is e raised to x into f of x plus c. So now if you try to write it in that form, denominator x plus 1 is there, so that's why numerator also try to write it in the form x plus 1 plus something. X minus 1 can be splitted as x plus 1 minus 2 upon x plus 1 whole cube as it is into dx. Okay, so this is 0 to 1 e raised to x into, let me write it into two terms. It is x plus 1 upon x plus 1 cube minus 2 upon x plus 1 cube. See here the first term x plus 1 one time, x plus 1 3 times. One time we can cancel x plus 1. 0 to 1 e raised to x into, cancelling x plus 1 once, we have 1 upon x plus 1 square minus 2 upon x plus 1 cube into dx. Now we may see that it is in the form of e raised to x into f of x plus f dash of x. You take f of x as 1 upon x plus 1 square and its derivative, sorry, here f dash of x, its derivative is minus 2 upon x plus 1 whole cube into dx. So what is its integral now? This integral is e raised to x into 1 upon x plus 1 square, that is e raised to x into f of x. I can write it as e raised to x upon x plus 1 square. Taking the lower limit and upper limit and substitute this. Substituting the upper limit, e raised to 1 upon 1 plus 1 2, 2 square is 4, minus of e raised to 0, that is 1 upon the denominator 0 plus 1 square, that is 1 square 1. Answer is what? Answer is e by 4 minus 1. We have a second option in this. Yes, now let us move on to third question. Third question is if x into x raised to 4 plus 1 into pi of x is equal to 1, then what is integration of pi of x with respect to x, with respect to x here from 1 to 2 it is. Let me separate this function pi of x. Pi of x is equal to 1 upon x into x raised to 4 plus 1. This is the given function pi of x is equal to. Now we need to integrate this. Let us take integration on both sides from 1 to 2. Integrating from 1 to 2 pi of x into dx is equal to right hand side integration of 1 upon x into x raised to 4 plus 1 into dx from 1 to 2 it is. Here you see, for this I will tell you one standard result, that is integration of 1 upon x into x raised to n plus 1 into dx. This is what? This is equal to, you remember this, it is 1 upon n into log of mod of x raised to n upon x raised to n plus 1. This standard result to remember. Okay, with the standard result answering the question, it is 1 upon, in place of n what is there here? 4 is there. So 1 by 4 into log of x raised to 4 upon x raised to 4 plus 1. You no need to write mod here because x power 4 makes it always positive. Okay, 1 to 2. Let us substitute upper limit, lower limit and evaluate it. 1 by 4 it is completely outside, let it be. Now substituting the upper limit, log of 2 raised to 4 16 divided by 16 plus 1 17, minus of substituting the lower limit, that is log of 1 upon 1 plus 1, that is 2. Okay, it is in the form of log of m minus log n. What is that? We know the formula, log m minus log n is equal to log of m by n. Yes, writing this as log of m by n, we have 1 by 4 into log of 16 by 17 by 1 by 2. This is 1 by 4 into log of 16 by 17 into 2 by 1. What is the answer now? 1 by 4 into log of 32 by 17. That is B answer, correct. Okay, this was your third question. Now let us move on to fourth question. Integration of 3 raised to root x upon root x from 0 to 2 dx is there. It is very simple. We can solve this with the help of integration by a substitution method. Let us substitute t is equal to root x here. What about its differentiating? Differentiating dt upon dx is equal to 1 upon root x is differentiation of root x is what? 1 upon 2 times root x. This can be written as 2 times dt is equal to 1 by root x into dx. Now according to this substitution we need to change even the upper limit and lower limit also. When the lower limit x is equal to 0, what is t equal to according to the substitution? This is root 0. Root 0 is 0. And when the upper limit x is equal to 2, now t is equal to, it is root 2. According to this substitution, suppose we change the integral. This is integration of 3 raised to t 1 by root x into dx is 2 dt. 2 is a constant multiple, I write it outside, and dt. Lower limit is 0, now also it is 0. Upper limit 2, according to this substitution, now it is root 2. We can integrate easily now. 2 outside as it is 3 raised to t integration. That is what? 3 raised to t upon log 3. It is like integration of a raised to x. Integral of a raised to x is a raised to x by log a, So in the same manner it is. Okay. 0 to root 2. Substituting 2 by log 3 is a constant, keep it outside. Substituting the upper limit, it is 3 raised to root 2 minus of substituting the lower limit, it is 0, so 3 raised to 0. Answer now here it is 2 by log 3 outside. Okay, you can write the answer here. 3 raised to 0 is 1. We have option A as the answer here. Yes, now let us move on to last question here. If in is equal to integration of tan raised to n theta with respect to theta from 0 to pi by 4, then I8 plus I6 is equal to what? I8 plus I6, n they have replaced with 8 and 6, that's all. What is I8? N is replaced with 8. So this is 0 to pi by 4 tan raised to, here n is replaced with 8 in the sense tan raised to 8 theta into d theta is I8. And what about I6? I6 is 0 to pi by 4 tan raised to 6 theta into d theta. Taking sum of these two, I8 plus I6 is equal to integrating from 0 to pi by 4. This is what? This is tan raised to 8 theta plus tan raised to 6 theta into d theta. Here 0 to pi by 4, what is common here? Tan raised to 6 is common. Take it tan raised to 6 theta common. We left with tan square theta plus 1 into d theta. 0 to pi by 4 tan raised to 6 theta as it is. 1 plus tan square theta is nothing but what? 1 plus tan square theta is nothing but secant square d theta. Now to integrate this, let me tell you one shortcut method, that is suppose a function is of the type integration of one function is there here, that is f of x, let us take, into f dash of x dx is there. One function into its differentiation. So this answer is what? This answer is f of x to the power, let me take n here, f of x to the power of n into f dash of x into dx. This its integral is f raised to n plus 1 upon n plus 1 plus c. You may remember this as a shortcut method. So here also you see this tan theta is there, tan theta is like f of x, n is 6 here, and its derivative, that is f dash of x, is nothing but secant square theta. We know that differentiation of tan theta is secant square theta. Okay. Answering this is f of x to the power of n plus 1 means tan theta to the power of 6 plus 1, that is 7 upon 7. Taking the lower limit and upper limit. Now substituting the upper limit, that is tan raised to 7 pi by 4. Tan pi by 4, tan 45 degrees, that is 1 upon 7, minus of substituting the lower limit, tan 0 is 0. Answer is 1 by 7. We have option D here. Yes, these were your 5 CET questions on integrals. Thank you.